This will be part 2 of Chapter 9, Analysis of Variance. Once again, our idea here is to compare more than two means. So let's get started with a randomized block design. In randomized blocks, you'll have two factors without replication. This means that you've got a one-to-one sample for each factor. It's not repeated. So we call the second factor the block because it may have some kind of effect on your response variable as well as the main treatment that we give it. Many times the blocking factor is a categorical variable, such as gender, then the levels would be male, female. Job title would be the factor with levels of CEO, vice president, manager, supervisor, and so on. Other times it could be an ordinal variable where we've got levels of low, medium, and high. This is my first example. HEB is tracking the average number of deliveries per week. They categorize their deliveries by item type and location. There was only one recording per item/location in the design, and it was not replicated. So the experiment would be defined as recording the average number of deliveries based on item type and location. The design is called randomized block. The factors are items and locations. The levels are the specific labels: pharmacy, food, cleaning, apartment, business, home. The response variable will be the average number of deliveries per week. That's always the thing we're getting the average of. Here's the data setup. We have blocking factors that require we randomly assign the subjects to the treatments within each block. So we have deliveries, item, location in columns for jump. However, in Excel, we have a data table. When I do the analysis of variance in jump, my output looks like this. I'll have two F ratios. The item and then the location was the block. So item has an F ratio of 100.83 with a p-value of 0.0004, and the block location has an F ratio of 9.14 with a p-value of 0.0322. Here are the setups of your hypotheses. Notice again we are using mu for the mean of pharmacy equals the mean of food equals the mean of cleaning products. HA, at least two means differ. So our F ratio is large, p-value small, we reject HO. So at least two of the means are different based on item type. Same thing for location. At least two of the means for apartments, business, and home are different. After deciding that at least two means differ based on item, we want to say which ones differ. So we go to what's called post hoc analysis, or in JUMP, it's referred to as multiple comparisons test. Looking at the chart, when the vertical lines in a category overlap on the y-axis, they're not significantly different. But when they don't overlap, they are. So when I look at the cleaning group, it does not overlap food or pharmacy, and it's higher on the y-axis. I can also use the connecting letters report. Different letters mean they're in different categories or have different means. So cleaning in category A is different from food and pharmacy in category B. And notice its mean is significantly higher. Placebos have been used as control groups in many medical or clinical trials. You've heard of this where the group receives a sugar pill rather than the actual medicine. This is to separate the imagined effects from a treatment versus the real effects. In business, if some kind of product has been scientifically proven, consumers may perceive a difference when there really was none. So to separate those real treatment effects from imagined ones, we use an ineffective control treatment called a placebo. Blinding is the deliberate withholding of the treatment details from individuals who might affect the outcome. There are two sources of unwanted bias in an experiment: those who might influence the results and those who evaluate the results. So the influencers would be the actual subjects, the administrators or technicians, and then the evaluators could be analysts, judges, or experimenters. If there's only one group where the information is withheld, then that's a single blind experiment. If both of these groups are withheld information, then it's a double-blind experiment, which is preferred. Confounding means that we have gotten data that was usually observational data rather than a true experiment, where they've already hooked together two factors. So if we had hooked the factors cleaning and home as one, or pharmacy and apartment deliveries as one, that would be a confounded variable. We want to try to avoid this. Lurking variables means there's another variable, a third one, not in the design, that's actually driving the response. So a lot of times the economy may be a lurking variable not taken into account in the actual experiment. So what's the difference between confounding and lurking? Confounding means that the levels incorporate more than one factor. Okay, it doesn't necessarily drive the companion factor. This concludes what we're going to cover for part 2. We'll be doing more examples from the book later on.